I'm extremely excited to talk about data structures such as linked list, hash tables, trees, and etc. But before that, let's quickly glance over our all too familiar data structure, arrays. Let's apply big O to our arrays so that we have a baseline against which we will compare all our data structures. So this is our array with index 0, 1, 2, 3 and values A, B, C, D, E, F, G. I'm really sorry, I just got carried away. Let's call this array ABCD. First, let's push this emoji at the end of this array. We will use array.push. Clearly, we just added this to the end of our array with index of 4. I think that it's making our array look bad, so let's just remove it. We are gonna use array.pop. I think that it was really easy to guess. Both of these were an O of 1 operation. Now let's focus on the other end of this array. Let's remove A. That is index of 0. We will use array.shift. This was O of 1. Now don't you notice a problem with this array? The indexes are all wrong. And now we are gonna have to tediously reindex this one by one. And finally we have a proper array. This was O of n. Our total time complexity would be O of 1 plus n. But I forgot to tell this to you before. We always drop the non-dominant terms. For example, if we have a big O of 1 plus n square, and square is not only the most dominant term, but is also the main factor by which our algorithm will grow as compared to these teeny tiny factors. So we are gonna just ignore them. Now let's get back to our shift method. As you might have already guessed, this is an O of n operation. Now our ABCD array looks a bit incomplete. It's missing an A. Let's add A back. We will use array.unshift A. Oh god. And again the indexes are all wrong. We are gonna have to reindex this again. This was again an O of n operation. Now let's add this emoji to the middle of this array. Let's add it to the index of 2. We will use array.splice 2, 0 emoji. This means we are going to add to the second index. We will delete 0 items and we will add this emoji. Again we have to reindex half of this array. What's the big O notation of this? Now you might think that it's O of half n. But what if we had to add this emoji to the first item? Then we will have to reindex the entirety of this array and it will become O of n. Big O always considers the worst case scenario. And also if you remember, we always drop these constants. Okay, from now on, I'm gonna ignore non-dominant terms and drop constants by default. Now let's move on to searching. So there are two ways to search in an array. Search by index and search by value. Let's run this code. Search by index is an O of 1 operation because arrays give us a direct access to its index. But when we search by value, like for example in this code, we will have to iterate to the item we have to search. And by now, I really hope you remember this is an O of n operation. So these index are a blessing in disguise. On one hand, they allow instant access to any value, but on the other hand, you have to reindex every time you add or remove an item from the beginning of an array. In conclusion, you can prefer arrays if you want to access items by index, or you constantly need to add or remove items from the end. Meanwhile, if you often find yourself searching by value or adding or removing an item from the beginning of the array might not be the best data structure for